Hello viewers, welcome to course Programming in C. Students want to make a career in computer and IT has to study the language C programming. And I, Suyog Dhut from Kekewak Polytechnic Nasik, I welcome you to the course Programming in C. Today's topic in this course is algorithm and flowchart, which is the basic things required in a programming. So after completion of this video, a student is able to understand the concept and importance of algorithm and flowchart in programming scenario. A student can write a algorithm for various problem statement and able to draw the flowchart for various problem statement. So let's go to the journey of algorithm and flowchart. So the first station in this session is algorithm. So what is the algorithm? It's very simple, a step-by-step procedure to solve a particular problem. Like we are doing a planning. If we have to go to somewhere that we will wake up at 7 p.m., then if rain is there, then we will not go. If rain is not there, then we will start the journey at 8 a.m. So stepwise we are doing a planning for some problem, some function. So same thing happens in programming language also. If you want to solve a particular problem, then you have to write first step by step procedure, and this process is nothing but a algorithm. Okay, so before writing any program, it is better practice to have to write a algorithm first. Now it's written in simple English language, it does not have any proper format or structure. Okay, in simple English language you have to write a algorithm like start, accept, do these things, then display, like this. So any person can write a algorithm, and by analyzing a algorithm that it does not contain any errors or does not going somewhere else, then can start writing a program, actual program. So step by step procedure to solve a particular problem is called as algorithm. Now let's see some example of algorithm, so then you can able to write a algorithm in your way. Now first thing I want to clear that it does not have any proper syntax or proper structure. So you can use any words, but the most important thing is that link is required. Okay, so let's see the first example. This is a algorithm to print addition of two numbers. So algorithm always starts with step number one, that is start, and ends with stop. So step number one is start. Step number two, accept first number from user. If I have to print addition of two numbers, then I have to accept first number from user. So let's say that first number is A. Next step, second number from user, that is B. After getting these two numbers, what is the next step? We will add this. So A plus B. After adding two numbers, we are getting one number. So that is C. And after getting a addition, we are displaying the addition, and that addition is nothing but C. So we are displaying it and then stop. So link is required. Suppose in step number 2, if I say perform addition, where are the two numbers? So that's why you have to write a algorithm. So you may change the number, you may change the wording, you may change the words, but linking is required. Now next example is to check the number is even or odd. So again, step number one, start. Step number two, accept number from user, that is A. Now third step, how to check number is even or odd. So if A modulus 2 equal to 0, so after performing modulus operation by 2, if answer is 0, then that number is even number. So if that thing is there, then display A is even number and go to step 5. Step 5 means stop. If it is not equal to 0, then you have to go to step number 4. So this is decision making statements. So in step number 4, you have to display that A is a odd number. So this is the second example of algorithm. Now this is something complex statement that to display class of student based on percentage. So student may have distinction, student may have first class, pass class or fail. So now see, let's see the algorithm. First is start. Second, accept percentage of student. Now third, if percentage is greater than 74, then we are saying that display distinction, and after display distinction we have to stop the process. So that's why I am writing go to step 7. If percentage is not greater than 74, then go to step number 4. Now in step number 4, next condition, if p means percentage greater than 59, then display first class. After displaying first class, go to step number 7. If both are not satisfied, then go to step number 5. In step number 5, if P is greater than 40, then display pass. Then go to step 7, that is stop. Otherwise, go to step number 6. And if student is not getting greater than 74 percentage, greater than 59 or greater than 40, it means it fails in an exam. So display fail, and after display fail, stop it. So I hope you understand how to write a algorithm for the given problem. Now next concept is nothing but a flow chart. Okay. So what do you mean by flow chart? A diagrammatical or pictorial representation of algorithm. So uh, if we are making a diagram of algorithm or pictorial representation of step by step to solve a particular problem, so then that diagram is called as a flow chart. So instead of referring a flow chart, instead of referring a algorithm, flow chart is always suitable. So to make a flowchart, predefined symbols are used. So some symbols are defined. You have to use that symbols. So we can say that it is a one kind of blueprint or a model of the output product. So suppose we have to make a home or a bungalow. So we are making a model of it, right? So step by step we have to go for that. So same concept is that, and general language is used in a flow chart for the any problem. So some symbols are used. So these are the common symbols that are used uh, for the flowchart making. So first one is oval shape, that is used to represent start of the flowchart and end of the flowchart. Then arrow is used to connect two shapes to each other. Okay. Then input output parallelogram is used to accept input or to show output, means accept display. For this purpose parallelogram is used. Then rectangle is used to show the process, like perform addition, calculate sum. So for this purpose rectangle is used. And most important, a diamond shape, which is used to take a decision, like if a mod 2 equal to 0, if percentage greater than 74. So that kind of things we are putting in a diamond shape. So diamond shape may have multiple outputs. So maximum two outputs are there for diamond shape. One arrow is going yes if that condition is satisfied, what to do, and no if that condition is not satisfied, what to do. So diamond shape have multiple output. Okay. So these are the common symbols used in a flow chart. Now let's see some example. Now this is the first flow chart to print sum of two numbers, addition of two numbers. So first I will use oval start, then I will accept the number, that is enter integer a, that is get a. So parallelogram is used. Then I get second number by using parallelogram, and these shapes are uh, connected to each other with the help of arrow. So wording is not important. Here you can say also accept number 1, that is A, accept number 2, that is B. Now third thing is I have to do some process in the sense A plus B. So that's why I am using a rectangle here. then I have to display that particular thing. So output is there. So that's why I'm using a parallelogram. And after completion of that, here you can say stop also, here you can say end also. Same thing can be do like this: accept A, accept B, sum is equal to A plus B, display sum and stop. So it doesn't have any predefined language that you have to use. You can use in your own way. Only the thing is that link cannot be break. Now second example to check number is even or odd. So start in an oval shape, then parallelogram, accept a number. Okay, now then diamond shape. So if number mod to equal to 0, so if it is yes, then print even. If it is no, then print odd. And after print even or odd, it will go to stop. So in this way, diamond shape is used. Now this is the most complicated flowchart to display grade based on marks, or based on marks the grade is there. Now see how it will work. Start, read marks. Now if marks are greater than 80, then what I say, display grade A, otherwise it will go to second condition. If the marks are in between 60 to 80, then it will say display grade B, otherwise next condition. If marks are in between 60 to 40, then display grade is equal to C. It means distinction, first class, pass class. If all these three conditions are not satisfied, then I will say display fail. And after performing display operation, go to stop. Okay. So in this way, you can have a flowchart uh, making for the given problem. Okay. So by using predefined symbol, you can have a flowchart for the given statement. So in the conclusion, algorithm and flowchart are the building blocks for the programming. It gives the basic idea about a way of solution before writing an actual program. So it is a good practice by the programmer to have algorithm and flowchart before writing a actual program. If you want to minimize the errors in program, then it is a better practice to write a algorithm and then make a flowchart for the given statement. So at the end of this session, I hope you understand the concept and the importance of algorithm and flowchart in a programming, and you can write a algorithm for the given problem statement, and you can draw the flowchart for the given problem statement. Thank you.